Do you feel the vibes?
Okay, so we first learned how to graph in this chapter, graphing exponential functions. So here we go. So I have here 2 to the power of x plus 1 minus 3, right? So the domain is always all real numbers. Whose phone is that? Okay, the asymptote is y equals, and it's this number, which in this case is -3. Okay. Now, the range is y also compared to -3, but why don't we leave that as, a blank right now? We're going to fill it in a minute. Okay, so here we're going to start graphing this. Let's put in y equals -3 right here first. Okay, now I'm going to put in here 0, 1, and 2. Okay, so here 2 to the power of 0 plus 1 is 1, minus 3. That's minus 1. 2 to the power of 2 minus 3, that's 1. 2 to the power of 3, that's 8 minus 3, that's equal to 5. So at 0, this is -1. At 1, this is 1. And at 2, this is 5. And when I graph, that's what it looks like. Now, first, the range. Because this graph sits above the asymptote, on top of the asymptote, vertically above, this is going to be greater than -3. And then the y-intercept is always when you plugged in x equals 0. So it's 0, comma, -1. And that is one way of how we can graph these. Okay, so remember, you have to have the asymptote, and you have to show the graph following the asymptote on the bottom, and then heading up very, very quickly in the top. Okay, now, go ahead and take out your calculators, please. All right, and we're going to do Doc B, and we're going to go into the graph. I'm going to show you a second way to do this. But before we do anything, don't plug anything in yet. I have this one here, -3 to the power of x plus 4. I'm going to fill in anything that I can fill in, okay? All this you should do without your calculator. The domain is always going to be all real numbers. The asymptote is going to be y equals what number? 4. And here it's going to be y compared to 4, which we can do in a little bit. Yeah.
If there's a negative for a function, does that mean the 4 is going to be less than?
Yes. Okay, so now let's go over here. So, yeah, so look, -3 to the power of x plus 4. Graph it, that's what it looks like. Okay, you see there is an asymptote there at 4. Now let's do Control T. Control T. And let's pick some numbers here, okay? You can pick any of these numbers. We definitely want a 0, and I get a 3. And then it's up to you. Do you want to pick -1 and 3.67? Do you want to pick 1, 1? It's up to you. Why don't I stick with integers? Okay? And you can graph it this way. So now, the asymptote is y equals 4. At 0, y equals 3. 1, 1, 2, -5. And we graph this way. And now, because it's less than, below the asymptote, this is going to be less than, okay, for the range. Again, as Sunny said, we also could have known that by this negative over here. When you have a negative in the front, this is always going to be less than. All right, yeah.
How do you know if the
Always dotted. Always dotted. Okay, so the y-intercept then is 0, comma 3. Okay? All right. So let's go ahead and do the next one. Yeah. If you put 3 points, it should be good enough. Okay? The range was y is less than 4. Okay, yes.
The y-intercept is always the one with
0. Correct. Okay, what's the domain for number 3? All real numbers. What's the asymptote? Y equals 0, and then here we're going to compare y to 0. So if you had to guess based on the sign in front of the function here, how many would say it would be greater than?
Yes. There's no reflection.
Okay. All right. So let's go ahead and put this here. Okay. All right. So let's go ahead and graph this. So I like to get rid of the table when I'm graphing just so I have more space here. Okay. So tab. Here I'm going to do in parentheses 1 over 3 to the power of x plus 1. Okay, so here we go. Now when I do control T. Okay, so look here. I have 1, I have 0.1, and all these numbers. When I move up a little bit at 0, it's 0.33. I definitely want the 0. I definitely want the 0 because that's the y-intercept. But look at over here. I have all these options that give me integers. It is up to you what numbers you want to pick. You don't have to stick to 0, 1, 2, but always have the 0, even if you get a decimal for it. So why don't we do, -2, -1, and 0. So -2 is 9, then 3, then 1. So -2 is 9. Oh, -2 is 3. Oh, what did I? 3, 1, and then this is 0.3. Sorry, I was off by 1. Okay, that's 0.3. So at -2, we're at 3.
We don't have to do it.
At -1, we're at 1. And then at 0, it's 0.33. You need to show me the y-intercept. I don't care how, ugly or pretty it looks. You have to show me. Okay, so there we go. You can put arrows or you don't have to put arrows. It's up to you. Okay, any questions on how to graph these? So now you know how to do it by hand. You know how to do it by graphing. Okay, yes.
For the quiz, do we have to write if it's okay or
Yes, I'll ask you. Okay, so this is greater than, and the y-intercept is 0, 0.3. If it's, okay, so for growth and decay, you have to look at this number that's being raised to the power of x. If that number is between 0 and 1, that's your B, then it's decay. But if that number is greater than 1, then it's growth. Okay.
So this one's, you don't know.
Decay, of course you know, because
It's just an X.
no, it's 1/3. This highlighted number.
Oh, it's that.
Okay. So all this was section 1, right? So here we can put that this is section 1. Here we're starting with section 2, 7.2. Okay. So to solve these equations, what we have to do
7.2 is
no, this is 7.1 worksheet. This is something completely different. These are not even the same problems that we're solving.
They were just the same problem.
No, they're not the same problems. This is what we're solving. I haven't even printed this yet. This is completely something else. Okay. Let's do this. So 3 to the power of x plus 2, or x minus 2, 9 cubed. So what we want to do is we want to make sure that these bases are the same number. Now, if this is a 3, Okay? I want to make the other one a 3 as well. So 3 to the power of x minus 2 is equal to, this number 9 is what? 3 squared. Okay? Yeah.
So, would it be allowed to just square the 3?
No. Because then you're changing it. But when you say the 9 is 3 squared, you're not changing it, you're just rewriting it. Yeah. So this is going to be to the power of 3. So that means I have 3 to the power of x minus 2 equal to 3 to the power of what? Somebody raise your hand. What is the new exponent of the 3 right now? 6. Thank you for raising your hands, but really raise your hands. Okay, so here, once the bases are now the same, you can set the exponents equal to each other. So x minus 2 equals 6, x is equal to 8. Okay. All right, here I have 1 over 5 and I have 25.
That's the answer?
That's the answer.
Or has nothing to do with the actual numbers?
Nope. Brand new answer. So here you have a different situation. You have a 1 over 5 and you have a 25. You can see that both of them are like derivatives of 5, right? They're variations of 5. So I want to write both of them as 5 to the power of something. So that's where the negative comes in. So if I have 1 over 5, another way to write that is 5 to the minus 1 to the power of x minus 4. Please put everything in parentheses. Equal to, the 25 is 5 squared to the power of 2x plus 1. Yes.
Why couldn't you just make the 25 like, or do like, you can't do a fraction of the 25?
I mean, you end up with the same. It's more complicated. So, no, it's better this way. So, yes. So now, here we're going to have this equal to this. So I say negative 1 x minus 4 is equal to 2 times 2x plus 1. Do you see all of these parentheses? If you don't have those parentheses, it's going to be all wrong. So now distribute. So I get negative x plus 4 equals 4x plus 2. Okay, now I'm going to add x to both sides. So I'm going to get 4 equal to 5x plus 2. Subtract 2. 2 equals 5x. Divide by 5. So x equals 2 over 5. Now, because the domain for exponential functions is always all real numbers, you don't have to worry about extraneous solutions. Okay, so that's one thing. Now, let's move on. Okay, next thing is write an exponential function that passes through the points 0, 3, and the other one. Okay, so when you hear the word exponential function, the formula is y equals a times b to the x. Okay, we need to know that. Times b to the x. A times b to the x. So now, here's what you need. If you're given these 2 points, you have to find the one point that's your y-intercept. So here, this is the y-intercept because it's 0 comma something, right? That's what we just talked about, right? When we were graphing, the y-intercept was always 0 comma a number. So if that's the y-intercept, that means that number, the non-zero number, that's your a, that's your initial value. Okay? So now, the other coordinate, that's going to be your x and y. Okay, now, we're going to plug all these things in. Okay? So, you ready? Okay, so let's plug in a, x, and y. Okay, so let's do it. So y is 2193.48 equal to 3 times b to the power of 4. Okay. All right. So now let's solve this for b. Okay. First thing, we're going to divide both sides by 3. Okay. So go ahead and plug this in.
What would B usually be?
Huh?
What would B usually be?
B is the rate. Okay, so go ahead and plug this in. Okay, so here we do get 731.16. So let's write that down. Is equal to b to the power of 4. Okay, to solve for b, I got to take the 4th root of both sides. So now take a look at what we're going to do here. When you go into your calculator, you're going to say 4th root of, instead of typing in all of these values, all of these digits, because that creates such a big opportunity for mistakes, you're going to do Control and the negative button on top of it, it's ANS, that's answer. So Control answer, that gives you the last answer in there. So you get 5.199. Yeah, usually it'll be, okay, usually it'll be specified how much to round your b. So we're going to estimate that to be 5.2. Now though, we're not done because it says, hang on, it says to write the exponential function. So the function is y equals 3 times 5.2 to the power of x. That is your function. You've got to have the 3 in there. You've got to have your b in there. And you've got to have x and y as variables x and y.
If we
So-
wrote it the first way, you could
Which way?
just answer like B4.
Correct, because I'm not asking for b. I'm asking for an exponential function. And so this number is always going to be the initial amount a, and so on. Okay. So, okay, so let's take a look at this one. Okay. So we start with 3,500 bacteria cells. After 5 hours, there are 15,000 cells. We want to write an exponential function that could be used to model the number of bacteria x hours if the number of bacteria changes at the same rate. So this should be an if. Okay, so the equation that we're going to use is y equals a times b to the x. All right, 1 second. All right, so the equation y equals a times b to the power of x. Okay, so again, just like here, we had to find an initial point, a y-intercept, the first amount. In this problem, this is the initial amount, right? That's your a. A is always your initial amount. And then, just like in this previous problem, we had to find the initial amount, and then we had to find some other situation where you have, a time and an amount. So here, this other value, 5 hours later, there are 15,000 cells. That's 5 comma 15,000. That is your x and y. Okay? So in any problem where you have to write an exponential function, you have to go and you have to search for the initial value a and then another x comma y.
We'll never get B though.
No. So so here y is 15,000 equals a is 3,500 times b and then to the power of 5. Okay, and then after that, the process is always the same. So we're going to divide both sides by 3,500. Okay. So here, Okay, plug these in because you don't want to get stuck with all these numbers and calculations. So we get 30 over 7. And you know what? I'm just going to leave it as 30 over 7. That's good enough. So 30 over 7 is equal to b to the power of 5. Okay, solve for b. Take a fifth root. Okay, so here, fifth root of, again, control answer. Get in the habit of doing that. Okay? Enter 1.3378. No, go at least to like 3 or 4 decimal places. Okay? I'll always tell you how many decimal places to use for your b. Okay, so now the equation is y equals, what was the initial amount? 3500, 1.3378 to the power of x. That's what we want. Okay. Next it says, how many bacteria cells would there be after, how many would there be after 10 hours? So now x is 10. That's, it stands for time. X is 10. So here we're going to say y equals 3,500, 1.3378 to the power of 10. Okay, let's see how we're going to plug this in. Okay, again, I want to minimize the numbers that you are actually typing in. So 3,500 times that number. What's that number? It's the last answer that we got, right? So control answer to the power of 10, and then you always get, the most accurate answer. So y is 64285.71. But we're talking about bacteria cells. So this is 64,280. How do we round this? Let's round it to the nearest 6 bacteria cells. Okay. Don't ever, always round correctly. Don't say, okay, we always have to round up. No, always just round mathematically and correctly. Okay, questions. Okay, the last type of problem is when we have compound interest, right? So let's take a look at what we've done so far. In our notes, right? In our notes, we started with graphs. So we just did a couple of those. We then did these equations. We just did a couple of those, right? We did some of these. Look, we did identical ones to these, right? Do you see that? I did an identical one to this first one here, and then an identical one to this bacteria, right? And then the last thing we did was compound interest in the notes, okay? So, okay, and then on the homework, you're going to do identical problems to these. I know because I just created these, right? This morning I created them. In fact, this is so similar to the one that's in the notes, right? That this is Jack, and then on your homework, the same problem, it's Jill, right? Because I just made them this morning, okay? So, okay, so let's take a look at this. A sum of 15,000 is deposited in an account that offers 2.3% interest compounded quarterly. When you see this, you know that this is the formula you're going to use. A equals P, 1 plus R over N to the power of NT. So, the first initial amount, now that's my P. Okay, there's always an initial amount. The rate is 2.3%, but when I write it in decimal, it's 0.023. Now, quarterly means N is what? N is 4 because quarterly happens 4 times in the year. We want to know what is the balance after 8 years, and that's your t. I'm sorry, t is equal to 8. Okay, so let's plug all this in. So A is 15,000. I'm sorry, right, but A is, and then, so 15,001 plus 0.023 over 4 to the power of 4 times 8. Don't forget that n is in the equation twice. So 4 on the bottom, 4 at the top. When you plug this in, it's got to be all in one shot. So here, 15,000, 1 plus 0.023 over 4 to the power of 4 times 8. Okay, when I press enter, I don't automatically copy down the answer because, oops, I did that twice. Because first, I want to pause and I want to see, is the thing I typed in the same exact thing as what I intended to type in? Or because if you do like, if you write plus instead of a minus and whatever, then it doesn't even look the same. So first check that. And now, this is 18020 point. And if this is money, then how do I round this if it's going to go to the second? Huh? Right, so it'll be what? 7, 4. Okay? Okay, so that's that. Any questions? Okay. Right, so then the